Swayam Prabha. Digital India. Educated India.
So, last class discussing about the case if the velocity of wave changes with depth, okay, and so these all are part of that low strain field test. So, I have already discussed what is low strain and what is high strain. So, in lateral I will discuss that when we will use the low strain property, when we will use the high strain property. So, let me first discuss about this low strain and high strain test methods. Then I will discuss that where I will use this low strain properties, where I will use the high strain properties. Okay, so now if I continue that case, that continuous change of velocity with depth, and I have derived that the total travel time t, that wave travel from top to the bottom, or the maximum depth where it attains the maximum velocity, where the maximum velocity is been attained or achieved. So now the net horizontal distance is already been calculated. Now we will start from here. So now if I write that, your sine ik by sine 90 degree, that is equal to Vk by Vmax, or you know the other way, that sine ik divided by Vk we can write as sine 90 degree by Vmax. That I have already. So I can write that 1 by Vmax, that will be equal to sine ik divided by Vk, because sine 90 degree is equal to 1, and that also I can write as sine I0 by V0. I0 is the initial inclination of the ray, okay, initial inclination of the ray. In that point V will be equal to V0, okay. So, and then I can write that is equal to P, which is a constant, or it is called the ray parameter, because this V0 is constant whatever the inclination is, but I0 is not constant, it depends on the ray that is received by the geophone or receiver. Similarly, Vmax is also not constant, it varies with the distance of geophone from the source, because if your distance from the source is high, distance of geophone from the source is high, then it will reach a higher depth, or the Vmax will increase, or velocity will increase. Similarly, I0 also. So, I0 is not constant, it depends on the ray. Vmax is also not constant, it depends on the ray that is received by the receiver, but V0 is constant whatever the ray is, because that is the velocity at z equal to 0, that is constant, okay. So, but that's why it is called ray P, which is, we can say, that is for ray parameter, constant for a particular ray, okay. So, it is a ray parameter Clear? Now we know that V equal to K dash Z plus V0. Okay. Now from the T, expression of T, that is the expression of T, that is I can now, this summation I can write in terms of integration. So I can write T is equal to 0 to, this is del zk, so this will be z max. What is z max? The maximum depth the wave will reach, that is z max. Now for example, if this is a particular, or you can say this is a particular ray, so from top to the bottom, the vertical depth, that is z max, where the velocity is v max. Okay, so that means it will be z max, then here it is dz, then divided by your vk, so this will be say v and root over 1 minus p square v square. How I am writing that? Because here I am writing that my, that is written that v is equal to v0 plus k dash z. Now at kth level, vk, that will be equal to v0 plus k dash into z, because that is at any depth z. So that I am writing that velocity is at the kth layer velocity. Okay, so Vk is replaced by V. So that means I can write that Vk is replaced by V. And similarly, 1 by Vmax, that is replaced by 1 by Vmax replaced by P. So 1 by Vmax is replaced by P. Now if you put it here, it will be Vk, that will be equal to V, the root over 1 minus V square into 1 by Vmax, so it will be P square. So that I have written here. Similarly, the and x will be what? 0 to z max. Okay, so this will be again Vp root over 1 by V square P square. Okay, so that I can write that it will be PV or Vp, then V, sorry, V is not there. So this will be root over 1 by 1 minus V square P square dz. Okay. Now if I do the integration, then I will get, or here that V I can replace again. So 0 to z max, so that is dz. V I am replacing with V0 plus z, that is V or Vk, then root over 1 minus P square V0 plus K dash Z whole square. Okay, and similarly I can write x is equal to 0 to z max, then P V0 plus K dash Z, then root over 1 minus P square V0 plus Kz whole square dz. Now after integration, I will get that x is equal to 1 by k dash p, small p actually this is k dash p, then 1 minus p square b0 square to the power half minus 1 minus p square v0 plus k dash z square to the power half. So, this is the expression. After integration, I will get the z x value 1 minus 1 by k dash p root over 1 minus p square v0 square to the power half, then 1 minus p square v0 plus k dash z square to the power half. Similarly, I will get the t after integration is 1 by k dash into ln, then v0 plus k dash z, then 1 plus root over 1 minus p0 v0 square, then v0 1 plus root over 1 minus p0 v0 k dash z square. Okay. So, I will get the t and the x. Okay. Now, from here, what I will get that I can write this x value. How I can write that? Let me explain that. Now, equation, if we have two equation, the x, I have not given any equation number. So, if I give equation, this is equation 1 and equation 2. Now, from equation 2, what I will do that if I take, from equation number 1. Now, from equation number 1, what I am doing that I am squaring both the sides and then rearrange it. If I square both the side and then rearrange it, then what I will get? That I will get this expression. What I will get? Let me explain that first. Then I will discuss about the other part. So that means here, if I square, then I can write x minus root over 1 minus p square v0 square divided by k dash p square plus z plus v0 by k dash whole square equal to 1 by k dash and p square. How I am getting that? How I am getting that? So, here basically I am taking this k dash p inside here, k dash p inside this, and if I take k dash p inside, or if I take this one, it will be from here. How I will get that? So, from this equation, if I take this one, this will be 1 by k dash p whole square. Okay, and this will be minus p will cancel, v0 square by k dash square. Okay, v0 square by k dash square. So, finally, this equation I am getting. So, that means from equation 1 I am getting this equation. So, if I rearrange this equation 1, I will get this equation. Now, this equation is is equation of what? This is a equation of circle. Okay, if you look at this equation, this is a equation of circle. So this is an equation circle. So now whose radius will be what? Whose radius will be, so this is also basically, this is whole square. This is whole square. So that means radius will be 1 by k dash p, and the center of the circle, will be, what will be the coordinate? The center, the x coordinate will be, or the, if I write the z coordinate or x coordinate will be your root over 1 minus p square v0 square divided by k dash p0, k dash p, and the z coordinate will be minus v0 by k dash. So what does it mean? It means that if this is the source, or O is the source, and if I draw the travel path of different rays with respect to different geophone, that is Z and this is X. Okay, so this is your geophone 1, say. This is geophone 2. This is geophone 3. This is my source. O is the source, G1, G2, G3 is the geophone position. And that means this is the equation of a circle. That means the travel path of the wave is a circle. That means it will follow a circular travel path. So that means if this is your geophone, so that means here, this case, it will follow this travel path. It's a circle. Then the next one, it will be another circle. Then the next one, it will be another circle. Okay. So this is the circle of all the paths. So this is circle. Clear? If it is changing with depth, then the travel path of the wave will be circle. Because we can get this from this equation, that is the equation of circle. Now, that means if you see this radius k dash is constant, but p is not constant. That means radius will change, and the radius, it depends on the ray, because p is a ray parameter. It depends on the ray, but k dash is a material parameter. So it depends on the material, and that is constant, whatever the ray is. Okay, wherever you place your geophone, the k dash will be same, but p will be different, because p is 1 by Vmax, and Vmax will be different for different ray. So that means radius is different for different geophone or different wave. But now come to the center. Center, V0 is constant, K dash constant. It independent to the ray. V0 is whatever the ray, the V0 will be material property, so that will be same for every ray. Clear? So V0 will be the velocity as z equal to 0. Similarly, K dash is also constant. So that means all the ray, this coordinate, this V0 by K dash, this will be constant. But here the first one, that is in terms of x. If you say this is x, this is z. So z coordinate for all the circle, center of the z coordinate for all the circle will be same. Okay, but the x coordinate will change. because there is again the P term is there, and P is a ray parameter. It is not material parameter, it is not constant. So now let me explain in more detail that this is V0 K minus. Now if I say this side is positive, so this side will be negative. Okay, so now we can say, suppose this line represents a distance which is V0 by K dash. This line represent V0 by K dash. See? So that means center of all the circles will lie on this line, because it is constant for all the circles, because V0 is constant, K0 is constant. So that means this will be the center C1. This will be the center for G2. This will be the center for G3 circle. So that means center will be for all the circle on this line. Clear? And this will be the radius R. For here, for this C2 circle, this will be the radius. This is R1, this is R2. You can see this is R3, though they are not drawn as per scale, but that means you can see the R1, R2, R3 are not constant, they are changing, and this equation is also showing that, because there is a P term is there, which is a ray parameter. So now from here I can write that from here, what is this value? This is center. So this will be the maximum depth. This will be the maximum depth the ray will achieve, Z max. This will be the maximum ray depth. This is the Z max form for this circle or this circle. This will be the maximum. Okay. So that means this circle will be here. So this will be the maximum. C2 for this will be the maximum. Because if you see at the center, that will be maximum, because wave will come from bottom to top. Here that will be the maximum depth it will reach. Here the velocity will be Vmax, and then it will go up and reach by the geophone 1, and similarly for 2, similarly for 3. So I can write that center to this distance will be Z max plus this one is V0 by K dash, that will be equal to radius of the circle. That will be equal to radius of the circle. So that will be equal to radius of the circle means K dash P. Clear? So I will get my Z max value, that will be equal to 1 by K dash P minus V0 by K dash. Clear? Or I can write that this is, I know that P is equal to 1 by V max, and that is equal to your sine I0 by V0, that I have already shown, that say sine I0 V max equal to sine I0 by V0, that is equal to P. Now you put that P value here. So this will be, this is 1 by K dash, that will be 1 by P minus V0. Okay. So now I can write 1 by K dash, P will be, that means V0 by sine I0 minus V0. So it will be, if I take V0 outside, K dash, it will be 1 by sine I0, that means cosec I0 minus 1. So Z max I will get by this expression, V0 by k dash cosec I0 minus 1. Now here what are the unknowns? First, if I know V0 and k dash, then I can get the velocity at any depth. So V0 is unknown, k dash is unknown, and then what would be the Z max? The maximum depth the wave will reach. That also we will get from this equation. Okay, so that also we will get from this equation. Now let me get that how I will get the k dash. How I will get the k dash? Now from this expression, equation number 1, you will get that from equation number 1, I will get that from equation number 1 from equation number 1. What I will get? I will get that x is equal to 1 by kp, 1 by k dash p, then 1 minus p square v0 square to the power half, then minus 1 minus p square, 1 minus p square plus v0 plus k dash z to the power square. So this, if I take second bracket, this is to the power half, then this one. So that is I am getting from x. Now what does this x means actually? This x is actually the half portion, because here what we have done, this x is representing what? This is actually the half of the circle, half of the circle. This is the x. The whole circle, it will be twice x. Clear? It will be twice x. So now let me put in this way, that now if I simplify this equation, that 1 by k dash p so 1 by k dash p, then I can write this is 1 minus, so v0 by v max whole square, because p0 is 1 by v max or p is 1 by v max. So I am replacing p by 1 by v max. So that will be so that is to the power half. Okay, then minus 1 minus 1 by v max square. So here again, when I am talking about this x, the whole x, so here the maximum z it will achieve is z max. So the maximum depth when it will achieve z max, though I can write v0 plus k dash z max, which is nothing but v max. I can write that, because here z means for a particular ray, z means the maximum z, that is z max for a particular ray, and that location in this point, what is my velocity? My velocity is v max when z is z max, right? Because at that point velocity is maximum. So now if I put that V0 plus K dash Z max, that will be V max. So basically 1 by P square is 1 by V max square, and this term, if I put Z max, this will be also V max square. Okay, and this total is half in third bracket. Okay, so basically this is 1 minus V max square by V max square. So this whole term will be 0. So finally I can write this is 1 by K dash P, and then it will be root over, this is up 1 minus V0 by V max whole square. Clear? Now further I can write 1 by K dash, this is V max, so 1 by V max, so the V max will be here because P is 1 by V max, so V max will be go up 1 minus V0 by V max whole square. Clear? But that is again I am talking about half of the distance. Now for full distance, that will be twice x, so this will be 2 V max by K. The full distance. If you take half distance, then it is V max by K dash root over 1 minus V0 by V max square, because we have taken the derivation for half distance, or we have taken this integration for half distance, because it is from top to bottom half, then other half it will be circle, so it is the other half, that will be the x twice x. Now here we can write that 1 by V max, that also I can write by, or 1 by V max, that will be equal to sin I0 by V0. Now if I put that value, so this will be twice 1 by V max. So the V max will be V0 by sin I0, and root over 1 minus, this will be V max, so V max will be V0 into sin I0 divided by V0. Okay, because I am just replacing V max, 1 by V max is equal to sin I0 V0, or V max is equal to V0 by sin I0. Clear? So now this will cancel out and this will be V square. This will be the whole term will be square. Okay, because this is whole term will be square. So V0 will cancel. So it is basically 1 minus sin square I0, which is root over. So that will be root over cos square I0. So it will be cos I0. So this term will be basically cos I0. So now if I write this thing, 2V0 by K dash, this will be cos I0 by sin I0. So final expression will be that 2V0 by K dash into cot I0. So my final expression will be 2x. That means the from here to here, the distance between source and geophone. X is the half distance between source and geophone. So the 2x will be the total distance between source and geophone. That will be equal to 2V0 by K dash into cot I0. And finally I will get the K dash is equal to, or if you write this is capital X or X total, 2x is X total, then it will be 2V0 by X total into cot I0. So this is another equation. So these two expressions are very important. Okay, that is Z max V0 K dash V0 by K dash cosec I0 minus 1, and this is the x total K dash, how I will get, equal to 2 V0 by x total cot I0. Okay. So from here, if I give a boundary between the things that I have discussed, so that will be easier for you. So if I remove this part, so then it will be okay. So now here, now if I write, this is my center, this is basically center whose coordinate x comma z. Okay, so x coordinate is this one, z coordinate is this one, and this way I have derived it. Clear? And then I will get z max by this. I will get the z max by using these expression. And now from equation 1, I will get finally the k dash also by using these expression. Okay. So now this is probably the end of all the different cases that I have discussed. What are the cases I have discussed? I have discussed the seismic reflection test for horizontal layering, for inclined layering. I have discussed seismic refraction test for horizontal layering, inclined layering, and a layer where itself the velocity is changing with depth or continuous change in velocity with depth. But in previous case, in a particular layer, the velocity is constant. But in the last case that I have discussed, that where velocity, there is a continuous change in velocity with depth. Okay. So now in the next class, I will solve a few numerical problems or example problems where you will show ultimately we have done so many derivations, so many equations. So ultimately, how we will use them to get the velocity of the wave and the thickness, and as well as from the velocity what soil parameter we will get. Thank you.